Okay, so I'll probably say more about this when we're actually on the computer, but I just wanted to talk a little bit about how to tell MATLAB or Octave that you're passing a function in. And so there's a couple ways to define a function and pass that function into an algorithm. So remember now, what we're looking at is we have this function here, Euler forward, and we're trying to figure out how to define all of these terms in here. Now t init is going to be a scalar, right? So that's easy. Y init is a scalar, t final is a scalar, h is a scalar. Well, okay, scalar. The only thing here is this is a function, and actually it's something called a function handle. So here's an example of how we might use this. So I'm going to try to solve y prime equals t squared minus y squared times the sine of y, with y of 0 equals minus 1, and I need to find or compute y of 1 with step size 0.1. Okay, and so solution. I'm going to define my function f, so this is what I'm going to type into MATLAB. F equals at, this is the at sign, that doesn't look very much like an at sign, okay, that's the at sign, right, ty, and then we just write in our function t. I'm going to use a dot exponent, just in case the t that gets passed in is actually a vector instead of a scalar, and then it will still be defined component wise. So I'm going to use dots for everything, dot star and dot exponent, and this again will be sure that even if y and t are vectors, this will still work. Okay, now we just define our t0 to be 0, y is 0. I don't want y of 0, I want y0 to be negative 1, semicolons in between. Final time, tf will be 1, semicolon, and then my h is my step size, 0.1, semicolon. Good. So now finally I will just type in t comma y is equal to Euler forward with an underscore there, f t0 y0 tf and h, and you're done. So what comes out, t and y will be computed, and so often it's nice to be able to see those as a graph, and so once it's finished you might just say plot ty. Now this is just going to plot the curve. It's going to try to plot the curve nicely as a smooth line or a smooth curve. So what I might say is I might use a apostrophe here, R0 with yeah, that's a 0. No, that's an O. That's an O, not a 0, with a hyphen there. And so what this does is the R means red, the O is the, we're going to just plot the points as circles, and then the curve is to also draw the curve. So if you leave off the hyphen and just leave RO, it'll just be the dot. The graph will look something like this. And then if you put in the hyphen too, it'll connect the dots as well. Good. Okay, so that's the first way of defining a function. The second way of defining a function is to use an M file. By that I mean in the editor in Octave, or just on any text editor, we'll save the following. We're going to type in function, and then dy is the output. That's the derivative of y. Let's just call it myfunc for my function, parenthesis ty. So this function is just going to produce the derivative, and so in this case dy is going to be t squared minus y squared, right, dot times sine y, semicolon, end. Okay, and then I'm going to save this as myfunc dot m. There's no white space there. Okay, and then when you're in MATLAB, you would type in like t0 equals 0, y0 equals -1, tf equals 1, h equals 0.1. Those are all the parameters we had before. And then in ty here, or when we call Euler forward, do you know what we're going to do? It's something that you may not expect, and that is we're going to put an @ sign here, at myfunc, and so that's called the function handle there, and then we'll have our t0, y0, tf, and h. Good. And so that'll produce the function. Now you might say, why am I going to go through all this trouble when I could just define my function this way? Well, the reason is because sometimes the derivative is going to be more complicated than that, and so if it's more complicated, you're going to want to off-put it as another folder or file, so you don't have to deal with it. Okay, we're going to talk about functions in MATLAB a lot more later, and so I'll stop here for now, and in the next video we're going to continue with a couple more methods. But in the homework, I'm asking you to, or the book is asking you to solve some of these differential equations using these methods. And so one part of the homework only asks you to do like 2 step sizes, or 2 steps. And so in that case, it's probably good just to do it by hand, just to get an idea, good feeling for what these algorithms do. And then the second part is to actually do it on the computer. Okay, and so for the computer, you're going to have to put in these files. I'm going to load up, or I'll put on the class website the Euler formula, or Euler forward.m file, so you can use that, and then see if you can modify that function for the other methods, and we'll talk about those too. Okay, so that's it for this video. The next one again will be covering something called backwards Euler and improved Euler. Okay, see you then.